You may just been, you may just been, that's.
What's your name?
Thank you. Oh. That was
Yes. That, I think the number of terms is, it's not 15. 11 terms.
Oh, I did, I started, it doesn't start at one, it starts at one.
Right.
Oh,
What? I did.
so it should be a 108.
No, it's fine. There's a, I think it's because of bonus question.
Oh. Oh. What did you get? Oh, does it make sense? Okay. Yeah. Let me see it. Let me see what you did. You just. This one. Oh, it's because it's the coefficient times r. It's not 1/6. You just did 1/6. Like you have to make sure you do the 32. And you just do the sum with this, you have to multiply all of this by 3. So actually what you do is you do 1/2. That should be 1/2, I think. So A1, when the first term was different than 1. A1. Yeah, because the first term. Where's the first term? No, it starts at 1. So the first term will be 1/2. So it's 1/2 divided by 5. And then my God, it's 3.
It's about.
Yeah, this was the second one. I got 2 subtracted off. And like, I did it wrong. I didn't. I started. See what you did.
George.
I'll be honest, it's actually not been though.
Yeah, the reason you got it wrong, you got it wrong for the same reason. So it doesn't
I
start.
was expecting to be a lot lower, to be honest.
It starts at it's like whatever.
Sean.
Yeah, so I got it wrong. Oh, wow. Because I was paying attention. You understand.
Anyone else? You'll have your test back.
Got it right, but I don't use the right test. What did you do? Oh, I don't know. You got that good points? I can check. Yes. Oh, Mark. Yeah, so it just integrates by the way I understand it. Did arc the version? Yes, it goes to pilot.
All right, let's see. Scott wrote rid of that.
Yeah. No, it's arc. That's why you gotta know like inverse. Because like you'll find that a lot of these theories actually do look to inverse training. Yeah, it was just the integral test. Because the integral test states that it's converging. Yeah, this also converges. Yeah, I know those are my the interval. Yeah, you need to
Any questions?
That one's on the right. You can see how. You gotta make them for this one. Also. It's a certain. They are the system. I mean, with the instance you're taking, this is our P. And when you do A, after those divided by P. So what happens there is you do, because when you're dividing by your number, and you multiply it by the 5,000. Just because, I only look at the highest degree on the other series, n squared divided by n, it's m to the negative third, so it should be 1 over. Because you, the highest term. Because you're just comparing it for a minute of like it basically, it's base series. How the base series is just 1 over n. Or you're not stupid, just you.
Do I have the test? Do you have any questions? Any problem on the test that was difficult or confusing? Any problem with the grading?
I can see it.
I posted the average on short review for this test, the average was
All my work's right.
84. Maybe because we had, this is actually a kind of difficult test, but I posted a bonus question. Which kind of grades the average. There's 10 points, the whole point of that, the actual credit. Any questions as you look through the test paper? Do you have any problems with grading? Is there any questions you want to be explained?
Yeah, but I put.
We do have a few students that scored higher than 100 because of the extra credit. So, if you feel like if you're shy, don't want to ask questions during the class, it feels great to ask me or after class and ask other students about their solutions. Any questions? We're moving on to parametric equation, slowly doing some calculus with parametric equation. So on the board, I have a question for determining the tangent line. The test paper, I have not added the actual credit yet, so for the homework, the actual credit is still in my. There's bonus questions, so I think for many of the. I will add the actual credit when I get to it. I just finished grading the test paper only. So whatever you have on paper is the test paper only, without the credit from. All right, the one on the question on the board, we're trying to determine the tangent line equation. You knew the answer, it's just a minute. This is a determining the equation of the tangent line. It's the equation of a line, so you gotta know the point, you have to have point is already there, 0.03. So you have to have a point, you also have to have a slope. So once you have the right slope.
1.6, 1%.
And no, I think I might have it wrong. Like that.
Yeah.
It was, yeah. Okay, that's right. Thank you.
It's a geometric.
I turn on the scanner. If you already knew the answer, you can submit it if you're online. For online students. Hidden and reminder. You can go see a test rate online. Yes.
I listened. I didn't make you wait.
So the points of calculation, if you want to determine the equation of pendulum, you gotta find the derivative and then assign a slope. So that was the question. So we know we already have a point. We know it's a parametric equation, so the equation, the point is still being determined by x and y. And then x minus x plus y zero. So, to determine any line, you need two information, the slope and the point. Right now, we have the point, we don't have the slope, but at least we can fill in the point. The point is 0, 3. So the equation goes y equal to mx minus 0 and then plus 3. So at that point, we're able to update our equation. Then the only thing that we need to know is m. So you're trying to determine the m. You need to know, to determine the m, there are two steps. So step 1, you gotta find the derivative. In this case, the derivative of parametric equation is the derivative of the y divided by the derivative of the x. So that was the formula, but that's not the m. The m has to be the derivative value at a given point. So determine the slope, or determine the m, you need to know the t value. And then you can calculate the m. In this question, which t value determined by the point, you see the 0 and 3. You see if x equal to 0, then t squared minus t equal to 0. T equal to 0 or t equal to 1. That's only the solution. So t equal to 0, you put it here, 0, 0, and then the y equal to 1. So it cannot be 0. T equal to 1, x equal to 0, y equal to 1, 3. So because of 0, 3, we gotta go through that process and solve the t. So that's this extra work for the t. 0, 3 is, see, you already have the answer. Let me, that's right. Little to the, yeah. So x equal to 0 means that t squared minus t equal to 0. And then the y equal to 3 means t squared plus t plus 1 equal to 3. Okay, so solving all that, we realize that the only number that satisfies both of these two requirements will be the t equal to 1. So we put in t equal to 1 in here. That's our m. And m equal to 2 times 1 plus 1 divided by 2 minus 1 and so on. That's your slope. So once you have the slope, then we can now have our equation of the line. I've already submitted your answer. Equation of the pendulum determined by the slope at the point. The point is 3, the slope is also, but just the finish at so that's. So now 1 also is 3, and down to 1, 2, 1, so it's 3. Right? So that's 3x plus, remember the y-intercept? Right? And x plus b, the b plus 3. The m is 2. Alexis, that's not right, but yours is. Find out. Okay, thank you. All right, as we mentioned over here, the calculation for the slope, you gotta figure out the right t value, and then you gotta put in the t value into the derivative with t equal to 1, the derivative, the m equal to 3. This is how you calculate the m equal to 3. And that's how we know this equal to 3. This is our equation of the line. The Poisson formula, or mx plus b, this will be the b. This will be the m equals 3, b equals 3. That's the equation of the tangent line. Thank you. That should be everybody. Attendance. About the test, now that you have your test in your hand, do you have any questions? Sure. Yes.
Overhead, do number 2.
10. Taylor expansion. The Taylor expansion, I have, erase all that. We have a function, let me write down the function, it's a square root function, f of x is equal to. It's equal to square root of x plus 1. The square root. Right, but we're trying to expand it at x equals 3. So you have to have some like understanding of what we are looking for. If you're expanding at x equal to 3 as a Taylor expansion, Taylor theory, what you are looking for is something like this. You're hoping to write this into a summation of, see, at x equal to 3, we're expanding it, so you kind of like x minus 3 power that you look for, x minus 3 to the power n. And then you have to have a coefficient. The coefficient is really the main concern here. So this is equal to a0 plus a1 x minus 3 plus a2. That would be the format we're looking for. I see many of you had all the coefficient right, but then you have x to the power 1, x to the power 2. It's not x because you're expanding at x equals 3. It has to be x minus 3 to the power 1, x minus 3 to the power 2. We're looking for a degree 3 polynomial. So you only expand it until the degree 3 term. So we don't have to go further to x minus 3 to the power 4, but at least you have to go to the 3. And see, there are a couple of you that you expanded to the square and then you stopped. So it's missing 1 or 2 terms if you only expanded the first 3 terms. You should have the first 4 terms in your expansion. All right, but this is a format, but this format does not provide the AI, or AN. The AN, according to Taylor, the formula for AN is nth derivative evaluated as 3, because we're expanding as 3, so that's 3. So divided by n factorial. So Taylor's theory allows us to figure out what will be the right way to have a power polynomial format of the function. Whatever function you want to represent, you can represent it into an infinite polynomial. So the main thing is try to find out all the A and see. Many of you had the right procedure, you had the right derivative, but you didn't really felt like you didn't construct it. Your final answer was missing, or you finished the derivative and calculate the derivative and you stopped there. So that could be the reason. It could be the time you ran out of time on test day. That could also be the reason that the 10 questions then was not finished. So let me look at the calculation. My writing was really awful, so let me try to type. The first derivative is equal to, start with fx. Fx is equal to square root of x plus 1. We should really write it as a power function for the purpose of differentiation. So x plus 1 to the power 1/2. So just writing 1/2 power there. So that's the original function. When you try to find the derivative, you can apply power rule. So the first derivative is equal to, when you try to find the derivative with power rule, you bring the power to the front. So it's actually 1/2 multiplied by x plus 1. You power go to the front according to power rule. Your power has to -1. So now the power is going to become -1/2 in the exponent. As an exponent, but that would be how it is. I'm going to try to finish all the derivative and then move on to evaluation. So you're going to have second derivative, which equal to the derivative of the first derivative. This time, you're going to multiply the power to over here. So what you're going to have, you end up having, I'm going to keep the numbers. So -1/2 multiplied by 1/2 is going to be -1/2 times 1/2. And then times x plus 1 to the power. This time the power has to -1. -1/2 minus 1 is -3/2. So that's what it looks like. And then this, we only have to do third derivative. So the third derivative equal to 1/2, 1/2, and then 3/2. So it's going to look like negative multiplied is going to be positive. So positive 1/1/2 times 1/2 times 3/2. Okay, and then time x plus 1 to the power of -5/2. Okay, so that's all the derivative. The benefit of keeping all the numbers is to allow you to see the pattern. You can see 1/2, 1/2, 1/2, all these multiplications have 2, 2, 2 in the denominator. So the third derivative of the denominator is 2 to the power 3. Numerator is 1, 1, 3. And that's pretty much, then you can imagine the next one will be a 5, right? So you can see the pattern in the numerator as 0 factorial and then 1 times 3, and then 1 times 3 times 5, and then 1 times 3 times 5 times 7. So we can follow that pattern, even if you have to go on fourth derivative, this derivative, you can already identify the pattern, and you can even write fn's derivative as 1 times, it's odd power, is a numerator, so it's 1, 3, 5, 7, 9, and so on. So maybe it's 2n minus 1 in that order. The denominator is 2 to the power n. Like the third derivative is 2 to 2 in the denominator, 2 to the power 3 in that. So the nth derivative will be 2 to the n in the denominator for the nth derivative. So there are writing more, meaning that you get to see more of the changes. So let's move on to the calculation, the value S3. F3 is the original function. The original function is a square root function. Square root of 3 plus 1 is 2. So that was 2. And then f of first derivative S3, we're going to plug in 3 to this function, plug in 3 there. And this is really 1 over square root of x plus 1. That's what it is. And then there's a 1/2 in the front if you write it out. So putting the 3 for this, you get a 2. This is actually 1/4. to this one. Okay, and then the f second derivative. Putting 3 in the second derivative, we put in 3, then we already have a 1/4 at the front, 1/4. And then you have, so this is really 1/4. I'm writing to the original meaning because I need to calculate it. And then this is going to be a negative power, so it's in the denominator. So it's square root of x plus 1, which is x plus 1 to the 1/2 power. But then there's a sign of 3 there. If you put in the 3, root of 3 plus 1 is 2. 2 to the power is 3, give you 8. So this is actually 1/8 that we're multiplying. That one was a function, this one was evaluation after you put in the 3. So this is actually 1/32. Okay, and then we move on to the third derivative. S3, the notation there is the 2 is in the denominator, so it's 8. 3/8 for the coefficient part, the variable part is 1/root of x plus 1, that's the x plus 1 to the 1/2 power, and then we have power 5. Okay, so then it will look like 3/8 times 1/2 to the power 5. That's the evaluation. This equals 3/256. So that's how it looks like. Are we okay there? Then we have to divide by the factorial, one more column. The first one, the 0 factorial is the first one, which will be a0. So for a0, a equal to zero's derivative divided by 0 factorial, which would essentially be 2 divided by 1. Then a1 is the first derivative value divided by 1 factorial, which is just 1/4. There's no change. Now a1, a0, then there a2. A2 is equal to the third derivative divided by 2 factorial. So it's going to be 1/32 divided by 2 factorial. That's like multiplying by 1/2. So with that 2 factorial there, right? So we get 1/64. Did I miss a negative sign there? There's a negative there. It should be -64. Negative. There's negative. It's alternating O's. Remember having that negative sign there. Whenever you take derivative, you multiply one more negative to the front. That's why it would alternate inside. And then a3 should be this number divided by 3 factorial. So it's going to be 3/256 divided by 3 factorial is multiply the reciprocals 1/6. 6 will be the 3 factorial. This cancels the 3, and then there's 2 left in the denominator. So it's 1/512. That's the a3. So this is replaced by 1/512. This is replaced by -1/64. This replaced by 1/4, so it's replaced by 2. And that will be the actual polynomial. So the answer to the question should be 2 plus 1/4 times x minus 3 to the power 1. And then minus 1/64 times x minus 3 to the power 2. And then plus 1/512 times x minus 3 to the power 2. All we have to do is replace all the coefficients. And then the focus of the calculation is figure out the coefficients, but your answer should be. Any question? I hope that explained that. Any other question? All right. I understand this exam is slightly harder, but because there's so many different variety of questions, so many different formula, we have to decide which one to choose. But when we assigned the question, I did try to make it, this is the integral test, that was a visual test. So we did try to specify the type of test we did. But I still see confusion as how do we determine, for example, the integral test, question 3, you guys either do not remember how to integrate, the 1 over x squared plus 1. It was supposed to be R10, and quite a few of you don't remember the integration anymore. And then another thing is, even if you find the integration value, you feel like the integration value is bigger than 1, and you define it as diverging. See, we only use 1 as a determination for root test and ratio test. We don't use 1 as a decision for the conversion, for the integral test. As long as the integration is finite, we would say converge. So there are some decision making that we kind of forget how it is. Right, so I do want to ask, like 30, the class response score. What do you think about the test? So one is how, what's your perception of the level of. So I want to start with the class. As far as, do you think the test is harder than expected? I try to make it as similar as possible to practice it. Sometimes made it a little too close to it, but hoping that it would hope none of them are surprising you. Your conjecture is really so assume that would be all the responses. Aaron, do you have a answer? Still listening to you. So A is 14 response. B is 4, C is 2, and D is 1. Did not take the test. I see. That's the test. Level of difficulty. All right, this is a yes or no question. So I wonder if you're happy with the way the number that you get. So this projector will affect this. So 12 yes and 5 no. So everybody have different situations.
I didn't get five spots.
Okay, sure. Thank you. It's 13 and 6. Everybody have different situation. Remember, if you choose to, if you want to, you can retake any of the past tests. The way to schedule it is to schedule with testing center. I think I did it one time. They have a testing center website that allows you to schedule the exams. But make sure that you know that if you click on the testing center website under academics, testing center website, and then one that says schedule exam. So click on schedule exam, it will lead you to a web page for choosing up the test. So that option is always open. You choose the first one and choose our class belong to the School of Science, Technology, and Math. Math, and my last name start with Y. The last name list. And you pick the 2 and And you probably have to log in and then you see it on calendar where you can choose your test dates. So that option will always be open. Other than that, well, for future purposes, you're always welcome to mention any issue or problem with certain type of question. So when I post the practice question set, that's my plan for the test. If you feel like certain question is not, it's difficult or a little hard to measure the ability of the student, you wish to switch to a different one, that's also okay. So it's always open for discussion, how it's being graded and how it's being tested. Whole point is whatever we're learning them, our tests actually reflect that. Any questions? All right, so that will be test 3. Feel free to let me know what you think or any other concerns. You're welcome to mention that after class. All right, so today we're gonna continue where we left, and I feel like we've been doing 9.3 for a really long time now. The whole idea is to be able to do calculus with parametric equation. So calculus involved 2. One is integration, one is differentiation. We have talked about the idea for differentiation. So having any parametric equation, you should be able to find the first derivative or calculate the second derivative. And you should be able to calculate the length of the curve, which is what we're talking about. That calculation. All right, sometimes the integration, especially length of curve, can be difficult, and we have to think about ways to figure out the number. So since this method is one, we also can reconcile. That link does not work anymore. I think you stop their online calculator, so that one have to use Excel as I was showing you last time. The art plans question, I assigned a couple of art plans question on Whiteboard. If you have any problem with those questions, you're welcome to mention that. We can do it together in class. Right. One more thing I want to mention is we can use integration to calculate surface area. This is something, again, that goes with arc lengths. And I think arc lengths and surface area was being introduced in the same section. So now we're introducing them also in the same section as we did with arc lengths. So if you want to calculate surface area, the formula for calculating surface area, if you remember, is 2 pi r ds. The 2 pi r provided calculation of the circumference. The ds provided calculation of the other dimension. So 2 pi r is a semi-perpendicular relation, like two perpendicular direction. That's what's making the calculation to two-dimensional measure. Okay, so here are the formula, and depend on what is your revolution. So if you're revolving about x-axis, then your radius should be the y value. Then whatever was the y value formula, in this case, suppose it's g of t, so that will be 2 pi r and then ds. ds would be the same as we mentioned last time. ds is the root of x, basically root of bx squared plus dy squared. And then if you are revolving about the y-axis, then your radius will be the x value. In this case, f t would be to calculate the surface area. This question. You can assign what that question looks like with your computation. We use that one as a little exercise, learn how to do it. So if we learn a skill or technique for certain computation research, certainly want to practice that. So here is this question. Let's see if I can assign a questions. I do remember I added a few questions to calculate the length. I assign the calculation. Second derivative. Okay, so this is a total length of the curve. Right, let's practice this question before we end the section. All right, suppose we want to calculate surface area according to our formula. Surface area is equal to, and follow the same idea. It's integration of 2 pi r ds. It's kind of like the formula for the geometric formula. This is an abstract notion, abstract formula. If you're applying this to solve your question, you have to identify those things. This is revolving about y-axis. So if you think of it, this is your axis. If you revolve about y-axis, this is your y, this is your x. What's your radius? If you revolve about y-axis, the center is on y-axis. This is the edge. From the center to the edge, that's your radius. So our radius is the x value. So if you revolve about y-axis, r equal to the x. We're not using x because x is not our variable. X equal to, in this case, 3t squared. So r equal to x equals 3t squared. And that goes in that r part, that one. And then we also need to know the s. ds is formulated by square root of derivative of x squared plus derivative of y squared. Separate, like x squared plus y squared, and then dt. Okay, so ds follow the Pythagorean theorem, and then we gonna be able to calculate this. This is equal to x squared is 3t differentiated, so the derivative of x equals 6t. Square 6t, we have 36t squared. And then we have to find the derivative of y. Derivative of y is 6t squared. So that will be square that, we have 36t to the power of 4. And then t is from 0 to 5, and that kind of set the whole calculation up. So SA surface area is equal to 0 to 5, 2 pi r. R is x, 2 pi times 3t squared. And then square root of, you can bring the 36 out. So we have 36t squared times 1 plus t squared dt. This is equal to, we can bring the 2 pi outside the integration. We can also bring the 3 outside the integration. So we bring 6 pi. And what else left is 0 to 5 t squared. And then the 36t squared also can be square rooted. It will be 6t. And then we have square root of 1 plus t squared. The outside is on power, inside we have 1 plus t squared. We can do a substitution method. If we make 1 plus t squared equal to u, then dt equal to 2t, right? Right. So we can, let's try it. We can do a substitution method. The computation over here. Basically, the answer to the surface area calculation will be the answer to the integral. Now we work on the calculation of the integral. Let me have that isolate the calculation and do it over here. Let's review how to calculate integration like this. The inside is degree 2. If we make a substitution, if substitution does not work, we have to do the tangent substitution, right? 1 plus t squared. If t equal to tangent, then 1 plus t tangent squared is secant squared. then you get it out of the integration, but that's a long way. If substitution were, this will be shorter. So we make u equal to 1 plus t squared. And then du would equal to 2t dt. Okay, so let's look at how it changed. We still have 6 pi, we still have the integration. We have 2t dt equal to du. That means 6t dt. Because I see a 6 dt, that there's a 6t, there's dt. So 6t dt equal to both sides multiplied by 6 equal to 3 du. So then we're gonna do a one-to-one course, one-to-one substitution. This is root of u. The 6t dt now become 3 times du. And then the t squared from that one, t squared equal to u minus 1. Right, so a simple substitution will work out. This you are already combined to the 3du. That one is t squared. T squared become u minus 1. That's our computation. Keep going. We have 3 multiplied by the 6. We have 18 pi on the outside. On the inside, we have u minus 1 times u to the power 1/2 du, which equal to 18 pi integration u to the power 1 plus 1/2 is 3/2 minus u 1 time u to the 1/2 is u to the 1/2 u. We can then now look at the whole thing as a power rule. Apply power rule, we have 18 pi u to the power of 5/2. It's really bad the way it looks. Let's type it. 5/2 as a power divided by 5/2. And that's the integration on that one. And then minus u to the 1/2 integrated would be u to the power of 1/2 plus 1 is 3/2. That's supposed to be the exponent and divided by 3/2. Okay, that finished the integration. But remember, we got a substitution going on, so the original antiderivative is 18 pi times 1 plus t squared to the power of 5/2 times, divided by 5/2 is times 2/5. Maybe I should put 2/5 before the power rule. This is 2/3 multiplied by 1 plus t squared to the power of 3/2. We're gonna put the integration limit 0 and 5. And then enter 0 and 5 as the p-value. We'll finish the calculation of the surface area. Any questions? Yes. How do you get your 3 divided by 3? It's multiplied by 3. Up here at 18 pi. And integration of 0/2 is u to the power of 1 times u to the 1. So what you did, you expand. We multiply, we not expanded, but you. Yes. Yeah. It's the distribution. It's u times u 1/2 is u 3/2. That makes sense. So I hope this reminds us that we should always practice our calculation of integration. It will always come down as some of the integration problems from other questions. Whatever you do and following sessions, we still have to do integration once in a while. Some of the integration are harder, some of the easier. This one, when I look at it, I realized that it was harder if we do a trig substitution. I did it one time. I made the t equal to t root data. It was a long process. But whichever method, most of the time they do use similar answers. Any question? So this is an example of calculating surface area. So the whole point is many of the things that we can do with a regular function defined by y equal to x, we can still do the same thing with parametric equation. Sometimes even more convenient because it provides symmetry. You have a formula for x, a formula for y, and t is a third variable that allows a lot of flexibility. Many of the functions are difficult to represent using regular rectangular equation. We can represent it with parametric equation. So this is something that would be helpful to know. All right, so while we devoted the whole chapter 9 to parametric equation, and let's talk about 9.4. Week 12 now. Um, 9.4, it's called Introduction to Polar Coordinates. In the sense, polar coordinate, if you think of it as a spatial parametric equation, but we're gonna work out that in 9.5. So far, right now, we're gonna try to understand the polar coordinate first. How many of you have already seen or heard of polar coordinates? Basically, it's in comparison with rectangular coordinate or Cartesian coordinate. With the regular coordinate system that we had, right? Regular coordinate system that we had, we use two number, x value and y value. Both of these two values represent distance. So the x value represents distance from the origin horizontally. The y value represent from point x, y, at any random point to the origin. What would be the vertical distance? So x and y is using x, y to locate a point is a coordinate system using two distance measure. Now, polar coordinates using a distance measure and an angular measure. So you have r and theta. R is a distance measure. It's a direct distance from the origin, which is a base point, to any point that you want to measure or any point you want to locate. So you locate the radius, r as in the initial letter of radius, and then you determine in that radius how much angle you're going to turn from one direction. So let's look at an example on the polar coordinates. Wonder if decimal still plot polar coordinates. Let's see. Obvious. Let's see if it does view. Okay. It doesn't do. The default coordinate system decimals is rectangular coordinate. Yes, it does. It's rectangular coordinate or complex coordinate plane. Anyway. All right. So in that case, I have to draw all these points in polar coordinate myself. All right. So let's look at an example. Basically, maybe I should provide more example on the rectangular coordinate and polar coordinate and compare them. Right, so that was our question. For example, if you have a coordinate system, let's say we get a point on the coordinate system. So let's say the coordinate was 2 and 3. Right, that means that the horizontal distance, this is the 2, and the vertical distance is 3. So if you want to locate anything using the rectangle coordinate, assuming that's a home and this is your target, you have to drive horizontally for 2 miles and vertically 3 miles, or this is the east, right? North, south, rectangle, but you can think of it as a way to locate a particular location. So from that location, you go this way and that way. So you have to have a rectangular turn in the process. So what's the polar coordinate? You can, in the polar coordinate, the direct distance will be one of the coordinates. So you draw a line from the origin to the given point, 2, 3, and then you will see the direct distance is, this is what we call R. So in this question, the X value is 2 and the Y value is 3. So R is like the Pythagorean, according to Pythagorean theorem, R is like the hypotenuse in the right triangle. So according to Pythagorean theorem, R squared is equal to X squared plus Y squared. So then the R, in this example, the R would equal to the square root of 2 squared plus 3 squared, which would be root of 13. So that if you are representing the same point with polar coordinate, the first coordinate will be root of 13. The second coordinate is supposed to be a theta. We use R and theta to locate a point. So the second point is supposed to be theta. Theta is a positive x-axis, and this angle that we draw, that angle is called theta. So if you want to know the angle of theta, because now we have trigonometry, if you know any trig value of theta, you can use inverse trig to find theta. In this case, you can, the most direct way is to identify tangent of the theta. So we can see tangent of theta is equal to tangent theta is equal to opposite over, equal to y over x. Y over x. Because in that triangle, the theta is on the opposite side, this adjacent side. Tangent in the right triangle is opposite over hypotenuse. So it's going to be 3 over 2. And then we can use our calculator, or you can just write notation. Theta equal to inverse tangent, theta equal to tangent inverse of 3 over 2. So we're able to identify the angle. In this question, the point there will be root of 13 and tangent inverse of 3 over 2. Okay, so for this question, of course, it's easier to determine to use the rectangular representation wise is simpler. But if you want to go directly from the origin to the point 2, 3, and you got to know how far do you go, you also need to know the direction. We go this way, or this way, or this way. So the angle and the distance is telling you, the angle tells you the direction, and the distance allows you in that direction how far to go. So polar coordinate provided another way to locate any given point. Polar coordinate is pretty popular in navigation. For example, if you're in the sea, or in the air, then most of the time we identify direct angle and find out how far do we go in that direction. All right, so let's look at all these examples and identify the right point. Now that we're talking about polar coordinate, we want to be able to plot it, to convert it from polar coordinate. You should be able to write a rectangular coordinate. From rectangular coordinate, you should be able to identify polar coordinate, so vice versa. So for example, the first point, it would be unit, the radius is 1. So you'll be drawing a circle of radius 1. And you'll be identifying the angle that was pi over 4. So from the origin, you're going to draw a ray at pi over 45 degree, right? And then the point that we are trying to locate is this point. And that would be the point A. Any question? Okay, so that's the first point. Second point, we have 1.5 and pi. Pi over 4 is 45 degrees. Pi is 180 degrees. That is 180 degrees from the positive x-axis. And then in that direction, we go 1.5. So for B, let's turn 180°. That's 180°. So you're gonna turn all the way 180° here. So the ray that we're drawing is this. We want 1.5. So the point that we find out, this is the one, all right, the one we, so that 1.5 is like here. So that would be the B. 180° angle and the distance is 1.5. Any question? C. C is, you see a negative angle. So how do we go negative angle? When it's negative angle, positive, well, it's a little review of pre-calculus. Positive angle, you go counterclockwise. Negative angle, you always start from the positive x-axis and you rotate clockwise. Counterclockwise is positive, clockwise is negative. Are we okay? Right, so we're gonna rotate negatives to pi/3 angle and try to draw it. So we're gonna rotate start from here, and we're gonna rotate negative pi/3 60, roughly 60° over here. It's negative 60°. Negative 60° there. And that's where you're gonna draw the array. That is the direction. We identify the direction, and in that direction, we're gonna go 2. The distance we're gonna go is 2. 2. So this is a 1. The circle is 1, and this is 2. So that will be the point C. Any question? Questions plotting the point. This one. If you go pi/4, we already have a pi/4. That would be the red array. The red array is pi/4. But how do we go -1 distance? See, in polar coordinate, the distance can be negative. So first we identify the positive direction. By -1, you mean in that direction, and this is a 0 distance, and you go opposite to the pi/4 angle. So it's right here. This is the P. So in the pi/4 direction, pi/4 is going this way. Are we okay there? This is pi/4. But if you go in this direction, you'll be going pi/4 pi/4 here. So if we change the angle to 5 pi/4, then the distance will be 1. So you can have multiple ways to represent the same point in polar. Any question? So polar coordinate is not unique. Okay. You guys know about polar coordinate, right? So remember, rectangular coordinate is 1-to-1. There's only one representation for one point. But for polar coordinate, you can have 2 different ways to represent the polar coordinate of the same point, or even more sometimes, depending on the purposes. Okay. That's understanding the graphic of it, and then we want to be able to convert one to another. This is converting between the rectangular coordinate and the polar coordinate. The one way is easier. I label these. So these formulas. Explain how do we use them. All right, this is for how do you get a rectangular coordinate. So suppose you already have the polar coordinate. You want to try to find the x value and y value. You want to determine the x and y. So in that direction, that conversion is to convert from polar to rectangular coordinate. Then you have formula. X equal to r times cosine theta, y equal to r times that. You realize this is pretty much parametric equation, right? For a circle, r times cosine for x, r times sine for y. So that one, there's a unique solution. When you try to convert from polar to rectangular, the answer is that's the x, that's the y. There's no second guessing. All right, but then below are the formula for how do you convert to polar coordinate. And then the situation is polar coordinate is not unique. You might have to look at additional requirement. Do you want R to be positive or negative? Do you want the theta to be between 0 and 2 pi or between negative pi and 2 pi? So you might want to add a few more conditions so that the answer will be unique. This is how do you convert from x, y to r and theta to find the polar coordinate of any given point. So how do we do it? If you want to determine the polar coordinate, you have to find the r value. You also have to find the theta value. To determine the r value, notice that because of the Pythagorean theorem in the right triangle, x squared plus y squared equals r squared. So the r equal to square root of x squared plus y squared. So if you want a positive r, that will be how you calculate r. Unless you want a negative r, unless negative r is allowed or negative r is preferred, then we might add a negative square root of x. And that's why we present it this way instead of just says r equal to square root, because r is allowed to be negative now, so we're using that one instead of having the r isolated. Another thing is we need to determine the angle, and that's even more not so clear. So here we have tangent theta equals y over x, and that's true. But is how do we find theta? The tangent theta is y over x. Theta equal to tangent inverse y over x. Not always. So it depends on which quadrant are we talking about. Basically, if you have a point, which we can clearly see the quadrant by the x value and y value. If you're given the x value, y value, you can immediately determine if it's both positive, it's in the first quadrant. If it's negative x, positive y, is in the second quadrant. If it's both negative, that's in the third quadrant. So x, y value is given, therefore the quadrant is given. Now, if it's in the first quadrant, right, and there's no problem, the theta equal to tangent inverse of y over x. Because in this case, you have positive y, you have positive x, and theta can be calculated using the inverse tangent. But if it's in the second quadrant, we have a problem because the tangent inverse of tangent, well, in this case, the x is negative now, the y is positive. So for tangent inverse y over x, you'll be getting a negative y over x. Tangent inverse of negative angle give you a. So if the actual point is in the second quadrant, then your angle should be bigger than 90, less than 180. But tangent inverse will only give you, that's the nature of the inverse tangent on our calculator. It only gives you angle that's between it's in here or in here. So for negative y over x, you will always get a tangent inverse in the fourth quadrant. So what do? You add a 180 degree to it. So theta equal to 180 degree plus bad. How to type it so it will be a little easier to read. The theta is equal to tangent inverse of arc10 of y over x. As tangent inverse y over x, you have to plus 183. Or you have to plus pi. Pi would be if you want a reading measure, plus 180 degree if you want a degree measure. So that's what we have to do if the angle is in the second quadrant or the point is in the second quadrant. Now, what if it's a fourth quadrant angle? Like right here, what if your point is here, your angle is here? Then of course you can do tangent inverse arctan tangent y over x, but then there's a little problem because arctan inverse tan of y over x, when y being negative, x being positive, it's negative angle. Tangent inverse of a negative value give you a negative angle, but many times we do not want to be theta to be negative, so we would add a 2 pi just to make sure the angle is fine, the quadrant is fine. But the reason we add is because we want to keep it positive. So we add 360 degree. That's how we handle the fourth quadrant angle. So I'm just saying, the angle, determination of the angle often depends on the quadrant. If it's a third quadrant, I believe, the tangent inverse y over x will be positive. Therefore, you'll be getting a first quadrant angle. You have to make it into the third quadrant by adding 183. So for the quadrant 3 situation, is the same thing as quadrant 2. Just copy that. So that's how we determine the angle, depending on which quadrant the angle is. Let's look at it. All right, so here we have two questions. The first question asks us to convert from polar coordinate to rectangular coordinate. The second question is convert from rectangular coordinate to polar coordinate. As I mentioned, the first one is to determine you have the r and theta. We try to determine x and y. The second question is we already have the x and y. We try to determine the r and theta. With the two. Okay, let's look at the first question. One, we have this is a r and this is a theta. According to our formula for the first point, we will calculate x is equal to r times cosine theta. R times cosine theta. The keyboard that put the theta. So the calculation will be r equal to. And then r equal to 2, theta equals 3 pi over 3, 2 pi over 3. So the calculation will be 2 times cosine of 2 pi over 3. Then we put it into the calculator to find its true value. Or if you knew that cosine 2 pi over 3 is 2 pi over 3 is cosine 120 degree, which is negative 1/2. So this is actually 2 times negative 1/2. If you use our calculator, I believe the answer will be negative. Any question? Can you try with your calculator? Have the same x for 35. Any question? Right, and then we can calculate the same, and then we have a y equal to r times sine theta. I don't have the theta on my keyboard, I'll just use t. R times sine theta, and the r is 2, and then sine 2 pi over 3. And then sine 2 pi over 3 is root 3 over 2 times 2. You will get a root 3. The answer would be root 3. That would be this one. We can confirm this by the graphing. So we're doing -1. And then the y value is root 3. So that would be this point. That would be that point. And you can also determine the angle. You can draw a line that is, see this is 2 pi over 3. So if we draw y equal tangent 2 pi over 3, 2 pi over 3. Okay, and then times x. So the tangent 2 pi over 3 will be the angle. The tangent theta equal to y over x. So times the x will be which give you that angle. So that's indicating that this one to have angle. This is 2 pi over 3. So we got the right angle, but as far as the distance, I think it's this is the one that would be 3. So 1 squared plus or 3 squared, that's 2. Distance over here is 2. You can also almost see it's a basis of 2, right? That one is pretty much the same distance. That one is two, so this one is also two. We only measure the distance there. So I think this is the right coordinates. Any question? We can run through the same process for the second one. This. Okay, the second point we want to calculate is the x value and y value, and you would run through the same process as we mentioned. The x value and y value is if you want to calculate the x value, x is equal to r times cosine theta, which then equal to -1 is the r and cosine. Then we have 5 pi over 4. We have to use our calculator. But cosine 5 pi over 4, 5 pi is the third quadrant. So the cosine will be negative -1, negative root 2 over 2. So the answer this will be equal to negative root 2 over 2 as our answer. Negative root 2 over 2. Any question? Do you have the same answer? Or do you have any issue? Okay. For the x. So that's the calculation for the x value. Because we need to know the x, y if you want to determine the rectangle coordinate. The y value is equal to r times sine theta. In this case, the theta equal to 5 pi over 4, so it's -1 times sine of 5 pi over 4. It's in the third quadrant, 5 pi over 4. So the cosine and sine both equal to negative root 2 over 2. So it's negative times negative. They're positive. They're both positive root 2 over 2. So this is equal to positive root 2 over 2. Any question? So graphically, you can also draw it. It's a like this. We have an angle at 5 pi over 4. It's this angle. That's the angle. We have this is the angle. That's a 5 pi over 4. And we want to go negative on that line in that direction. So if you have your point drawn here, that's when the distance equal to 0, distance equal to 1, distance equal to 2. So when the distance is -1, it was here. So that's negative. So that's positive. So the point identified by the 2 over 2 for x and y, you can see that first part. And it kind of makes sense when the radius is negative. Any question? And then we have the second question, which is try to determine the coordinate for we have rectangular coordinate, we try to determine the polar coordinate. That means you got to determine the r and also determine the theta. So let's do the r first. I prefer to use a positive r value. So r equal to root of x squared plus y squared. X is 1, y is 2. So it's going to be squared root of 1 squared plus 2 squared is 5. So that's the r. And then we also, that's the first quadrant angle. So the theta can be easier. We can use tangent inverse of 2 over 1, tangent inverse y over x, which is tangent inverse of 2. Right, and then you can use your calculator to find the angle. That's exactly the angle that you see when this is 1 and this is 2. Okay, this is a root 5. This angle is what we're looking for. And you can use tangent inverse coordinates. Any question? Last one is the -1 and 1. The -1 and 1 is landed on the second quadrant. That's -1. This is positive there. So it looks like the angle would be 3 pi over 4. The distance is 1 here and 1 here, just root 2. For this one, in the polar coordinate will be root 2 for the distance and 3 pi over 4. It's a special angle since I have x and y both equal distance one. So the angle is 35/4 because of the second part. Any question? So I guess this section, this whole section in 9.4, focus on reviewing for and being able to apply for it. And we are looking at the points, and then we probably move on to equation tomorrow. And that should be it for today. I hope it was okay. Please finish your homework on 9.3. If you have any difficulty, we'll talk about it. Thank you.